All right, so let's continue. Is everyone already back? All right, so just now we look into the hello packet. Okay, and next we look into the headers. Okay, in the headers. Inside the LSA headers. So just now, that is how it look like. That is on the head. Oh, hello packet headers with the packet. On top over here, there is the headers. Below is the packet type. So same thing, this is a packet type for the LSA headers. Under LSA headers, this is OSPF version 2 and this OSPF version 3. For the OSPF version 2, we have LSH, option, LS type, link state ID, advertised router, link state sequence numbers, and so the checksum as well as the length. So this is all the information that we inside the headers. Okay, so but when compared to the OSPF v3, what has been increased and what has been removed? Actually, nothing much information there have been done from here. You can see that under the LS type, they have no more options, but they will extend on the LS type. Okay, on the LS type. Under LS type, they have a LSA function code, U bit, S2 bit, and also the S1 bit. Remember just now when I mentioned the U bit over here, this is more for the unknown LSA, how they're handling on the unknown LSA. So for OSPF v2, they did not handle, they will just discard. Discard all the unknown LSA. But OSPF v3, they will have these capabilities on the U bit of 0 or 1. Okay, when the value of 0 indicate that the unknown LSA are processed as a LSA with the linked local addresses. When the value is 1, indicate the unknown LSA are processed based on the floating group identified by the S2 and S1 bit. So we either are going to define either carrying when they're carrying the link lockers, I will just send as a link lockers. Otherwise, I based on the S2 and S1 bit. So S2 and S1 bit is to mention that the script that you are flooding within your LSA, where you flood this information throughout on your LSA information. So how are you going to specify on this? So they have 2 bit there, and also they have 1 bit on the U bit, 2 bit on the S2 and S1. On the next page, they will showing you the information from here. This is on the U bit. Indicated how a router process the LSA that cannot be identified. It means that it's on the unknown LSA. So those unknown LSA is not the well-known LSA that we are talking about that do not support. In this case, how they are processed it, they can be processed based on 0, process unknown LSA that carrying link locker's address. Then the link locker address I will process accordingly. Let's say 1, I will store and flood the unknown LSA based on the S1 and S2 bit they are defined from here. So I have a S2, S1, I have 4 combination 0, 0, 0, 1, 1, 0, and 1, 1. Okay, so it depends on where is the area that you are sending this information. Okay, on the 0, 1, 0, 0, 0, 0 is link locals, 0, 1 is area scoop, and 1, 0 is the AS group, and 1, 1 is on the reserved. Okay, so you can see that from here in total they're going to provide 2 bit. Okay, the 2 bit from here. 1 bit is the U bit. Okay, 1 bit is a U bit. So you can see that that is on how it works from here. This field that will be on 16 bit over here. Okay, 16 bit. So the first bit is considered as a U bit, S2, S1, then 0, then 0, 0, 0, 0. This is 1 byte. Okay. in this case, it'd be much better to show you that what are the relationship from here. So let's say from here, that is on the bit 0, S2 is 0, S1 is 0, 0. And then behind is your LSA. Okay, this all is 0. So they have a okay, 1 byte and 1 byte. So first over here, they will just look into this 8 bits. So the U bit, S2 bit, S1 bit. Then the rest will be just 0, 0. Then this 1 byte as well, 0, 0, 0, 0, 0, 0, 0, 0. So this on the LSA type, the LSA function, okay, the function code. So when you have this as a 0, 0, 0, 0, 0, 0, 0, 0, it means that it belongs to the link lockers. Link lockers, they are sending from this is a 0, 0, 0, 0, 1, 0, 0, 0. Okay. So in this case, when you go change to the hexadecimal, it be 0, 0, 0, 8. Okay. That is considered as a link LSA. The link locker LSA. Okay, they're going to represent using this type. This type is representing by the 2 byte. It's a 0x0008. So they also have 0x2001. They have 2002, 2003. So that this number is depend on how they are flooding this information. Link locker scoop areas within the AS, and also the reserve. So that is the 3 way of their sending. So let's have a look from here. Let's say do you know how to differentiate of this? This is on the code of the LSA function code from 1 to 9. Yeah, 1 is router LSA, 2 is never LSA, 3 is inter areas, 4 is in inter area routers, 5 is AS externals, 6 is group membership, 7 is a type 7, 8 is link LSA, 9 is an intra-area prefix LSA. So actually, these are the 2 they are added in. The rest, they already have it. Yeah, they already have it. So number 6 is more into the multicast portion on the group membership LSA. This is more into the multicast. Okay. So based on the LS type, for these 2, where they belong to? They belong to link lockers, the locker link, or area, or AS. So when you convert this to become a binary, 2, it means that it's a 0, 0, 1, 0. Your first is U bit, S2 bit, S1 bit, and 0 bit. So it means that S1 bit is 1, is considered as a area script. So this message is only sent within your area only. Okay, within your area only. Then network LSA inter areas is all within the areas, except for this AS externals. This AS external is 4. 4 will be 0, 1, 0, 0. Okay, S2 is 1. When S2 is 1, it's sent within the AS scoop. So throughout the entire AS, you will get this AS scoop. Everybody inside the AS you receive, they're using this. So they only have 3 ways. And you can see that on this number 8, 0, 0. Okay, 0, 0. Okay, 0, 0 means that it's only sent within the link lockers only. I will just send to you, you just send to me within the same link. That's all. That's on the link LSA. Is that okay? So this is where you differentiate that where this LSA they're going to be sent into. They are sent into area, AS, link layers. That's a 3 method. Because of the 1, 1 as a reserve. Okay, this has been reserved. I will not compare at all. Is that okay? For the LSA function code that we have in OSPF v3, we have OSPF LSA 1 to 9 for OSPF v3. Router LSA, network LSA, inter-area prefix, inter-area routers, AS external, group membership type 7. This one is considered as an SSA, okay? Link LSA and the intra-area prefix LSA. So for all these LSA, later we're going to go in through one by one to describe one at a time what are the differences for all the LSA they show from here. Okay, we go through one at a time later part. So first you need to know how this type has been differentiated using the hexadecimal. 2, that is on the area. 4 is for the AS. 0 is for link locals. Okay, so this is how we need to differentiate first. For the functionality, later we go in more in depth on this. Is okay? Next. The next over here is on the link state ID. So remember that every single, when you configure OSPF, when you exchange the database, they have a link state ID to identify that who they are, what information they belong to. Okay, like in the OSPF v2, when a router LSA, they're using the router IDs. But for the OSPF v3, they're using the local unique 32-bit integrals. They're using their own integrals to perform that. Okay, they will just generate a unique numbers, unique 32-bit integrals to represent this is a router LSA. Okay, they do not have using the router ID. They're not using router ID. They're using a special unique numbers of the 32-bit integral as your link state IDs. For network LSA, it's a IPv4 network segment where the DR reside to, and by OSPF v3, it's just the ID of the DR interface. So on the DR interface, it should have an ID on that to represent that, oh, this is the DR interface that they're using their own IDs. Type 4, router IDs, but in OSPF v3, they're using the Unit 32, Unit 32, Unit 32. So most of the time in the OSPF v3, they're going to have a unique numbers to identify that who they are. What are the link state information that are representing to? Okay, that will be differences compared to OSPF v2. Okay, even those the type 357, OSPF v3 also using the unique 32-bit integral to representing. But for the OSPF v2, they're using the network segment, the exact segment. But for OSPF v3, they're not. They're using just the integrals. And for link LSA, intra-area prefix LSA, that's not happening under OSPF v3. Yeah, they're going to create it under the OSPF v3. So this is what's the extra that we have into the OSPF v3. 2 more LSA extra. Okay, 2 extra on the LSA inside the OSPF v3. All right. Okay. Why don't I do it like this? Instead of just talk like this, let me just show you the differences first. I'm going to share you the lab on the OSPF. Okay, hold on. Let me just copy the lab and share it to you. Just give me a second. Hold on. Let me let the device started first. I will show you the differences on the router IDs. What are the system information link state IDs that we show under OSPF v2? So in this case, it will better comparison between OSPF v2 and OSPF v3. So from here, I just show it to you. I just showcase to you how this information will be done. Later, we're going to do it together with the OSPF v3. OSPF v2, I will just show from my side, okay? So from here, I will just build a basic one and show you that what I mentioned about how this information is being shown into the OSPF v2 first. So I just do a simple one. Okay. They will have two areas here. So I have an area 0 and also on the area 1. So from here, I will just do a quick one. Interface gate 001. Okay, I will just do everything at the same time. So I think that all this configuration you should know how to define already. So this is just a basic OSPF that I perform from here. And on the last routers, sorry, okay, so I will just perform the basic OSPF has been defined between R1, R2, and R3. So over here, I will just want to show you that how's the how's the information on the database look like. Okay, first I go to router 2, display OSPF peer brief. Make sure the peer has been up on both sides, on R1 and also on R3. Okay, this peer is on up state. So in this case, now the next step I want to show you is how they're going to be checked on the database. So I check display OSPF LSDB. So at the moment over here, I have a router LSA, network LSA, and also the LSA type 3, some network, summary network type 3. So you can see that router LSA, they show the link state ID is under router IDs. Okay, router IDs. And 1.1 is router IDs. They are defined. And the layer 2, the LSA type 2, network LSA, they show that who is the DR. The DR is the one who send this information back to the database. Okay, I will send to alert that, hey, I'm the DR, 12.1.1.2 as the DR. Then for the LSA type 3, they have 23110 and 3333. This is type 3. Type 3 is always the that detail, the detail of the destination, that is where they are learned from. Okay, let's say right now on R3, I will just add on one more interface. Interface loopback 1, IP address 100.111.32, and I go to the OSPF 1, import route direct. I import direct into the OSPF. So from here right now, you should see this. In my extended, they have 100.111.3333.23.110. Because my direct, it means that everything will be imported already. Okay, everything is being imported. But it's okay, it doesn't matter. This is a basic showcase. So you can see that on the type 5 is a destination. This is a destination, they will show it to you. Okay, 100.111. And also for the type 4, type 4 it tell you that, oh, we want to go to this ASBR 3.3.3.3, who sent to you? The ABR. The 2.2.2.2. It's the ABR is converted. So you can see that under R3, display OSPF, LSDB. You do not see any ASBR, LSA. It's only type 1, type 2, type 3, and also the type 5. So far, okay? So this is what they are showing from here. Okay, they said that the router ID, the IPv4 segment, the router ID, the IPv4 segment. So that is how we recognizing under OSPF v2. And later I will show you that how the OSPF v3 under the LSID is look like. Okay, this one is alright for the version 2. It's okay. Right now I'll open up the version 3 and show it to you. Okay, just let it come up. Then I'll show you that what are the differences compared to these two. Okay. Okay. Let me just do a quick one to enable this information first. Let me just double check. So you can see that on the router one over here, what I have information that I have, link state IDs. You see that it's just a unique 32-bit information 0004 000 router LSA 001 3333. For the inter areas, okay, inter areas prefix. Okay, inter area prefix. That is on the this one. Also using the local unique 32-bit information as well. This router, sorry, router is also using this IDs. Yeah, ID of the DR interface. So they're going to show you the different information from here. So you need to know that what information. This is on the inter-area routers and inter-area prefix. Routers, this is on the type 4. Where's your ASPR? And this is on your intra areas. This is your AS external areas. So the number that we show from here, you can't really understand where they are come from. Okay, it's not like how we did on the OSPF v2. It'll be very clear that where they are. Okay, where you see that what are the router IDs and also you know that what is the IPv4 segment. But for this, you can't get the information only until you get the detailed status from the LSDB. Okay, you can check on the inter areas. Hold on, it should be inter prefix. So you have to go into the inside inter prefix to set that, oh, this is the prefix I'm advertising. So you need to go in detail to check. Not like OSPF Vision 2, you can just easily see direct from the database. Okay, that is some of things, the difference between OSPF v2 and OSPF v3. Okay, they're going to just give you this ideas information. Or those over here is just consider all the unique IDs. Yeah, unique IDs. So far, okay? For the OSPF v2 and OSPF v3, what's the differences between these two? No problem, huh? So I will just give you ideas how it look like. Definitely later, we also need to configure it together how this OSPF version 3 need to be done. Let me stop first. Later, after our lunch, then I'm going to go for that, okay? So that is on the link state ID. They will show under the database. And the next one is on the LSA type differences. What are the difference of the LS type that we have in the OSPF v2 and compared to the OSPF v3? So what the differences in between? So you go to one by one. OSPF v2, OSPF v3. the router LSA, router LSA. They have both router LSA. Never LSA, never LSA. Never some LSA, you change to inter area prefix LSA. This is what there has been changed. And ASPR LSA and inter area LSA, they changed the name. AS external, and also the last two is created, the link LSA and also the intra areas prefix LSA. This is what they're added in. Okay. Under OSPF v3, the first router LSA they provided from here, the name are the same, but the function also be similar. However, this type of the LSA does not describe the address information of the OSPF v3 and is only the describe the topology of the routing domain. You still remember that in the basic router LSA in OSPF v2, they're going to give you the ideas of the topology and the information that I'm forwarding. They have two information, IP information, the route information, as well as the topology. But for this OSPF v3 router LSA, they only provide the topology of the routing domain. They are not involved with the information that what route that you have advertised. Whatever route you advertise, it comes from the new link LSA and also the intra area prefix. This is where they advertise the prefix from. But for the router LSA, they just give you ideas that, oh, this device is connecting to which device. They show you the topology itself only. Okay, which topology right now they're interconnected in between. It's sending through the router LSA. Okay. So the next network LSA, the same. Network LSA is just to tell you that who is the DR. Okay. The function will be the same. Who is the DR? The network LSA. Then next, a network summary LSA on the OSPF v3, they have changed to inter area prefix LSA. That's the function is the same, that just that they have a different name. So it means that whichever from the intra areas, when I go to the inter areas, I doing the translate to become the inter area prefix. Okay, that is on the type 3. Okay, this is on the inter areas. So it's the same function that we're showing on the network LSA. Yeah, the network summary LSA, sorry. Okay or not? So that is on the inter areas. You can see that under inter areas, there's also another one is called inter area router LSA. So what's the difference between prefix and routers? So you need to differentiate these two. Prefix, it means that use a prefix, the network, the IP route they advertise as a prefix. The routers, this one is just meant for the ASPR. Just to introduce who is your ASPR. Okay, who is your ASPR that advertising this AS external route by using the inter area router LSA. It's the same function that compared to the ASPR summary. Okay, ASPR summary. So they have no difference. So okay. Okay, then the next one is on the AS external LSA. AS external LSA, the function will be the same. This one is just for more the external information. And the last two, the new LSA they added two new LSA into it. These two new LSA, they are handling what information? They're handling the intra areas. They're handling on the intra area, intra areas. Sorry. So first on the intra area, this is on the link layers. This is only between the same link. This is all the intra. This one will be very similar to the router LSA. Okay, router LSA that we are talking about. How they're going to exchange using the router LSA. So far, okay? On the intra areas and also the link LSA. For this OSPF version 3 LSA. This is all the LSA they are provided inside the OSPF v3. So they have a lot, about 9, but the functionality is very similar to OSPF v2, except they added 2 more new LSA, the link LSA and also the intra-area prefix LSA. These are the 2 LSA they added in. Any questions so far up to this point? Okay, let's say there's no question, then we go for next one. We check what are the differences of the LSA that we go through. We go through one by one. Okay, so first over here, they will show you the prefix. Okay, the prefix of the option field. So what's the difference compared to OSPF v2 and OSPF v3? So inside the prefix presentation method, there were some changes inside the prefix option field. The field is used to describe the features of the prefix so that the system can perform corresponding judgment and process when different routes are calculated. So what type of route they calculated from here is they have a NU, LA, MC, and the P bit. So that's on the prefix option in total they provide. There's 1 byte, but this is only the bit they're using. First is called as a NU, non-unicast. Okay, non-unicast. If this bit is set to 1, the prefix is not considered in the IPv6 unicast route calculation. They consider other route. It's not a unicast, it could be a multicast or any cast. LA, it means that they belong to the interface address of the routers. Okay, it's a local interface addresses. And MC is on the multicast route calculation. So otherwise, this is also not considered as a multicast. So it's either this is 1 or this is 1. Okay, and the P is a propagate bit. This bit needs to be set to 1 if your NSSA need to be advertised by the ABR. So you need to advertising this into the ABR environment. You need to have this propagation bit set as 1 to allow your NSSA to advertising by the ABR. So ABR will translate it to become the AS externals. These are the 4 different bits for the router to indicate that what type of information they are sending. Either sending a unicast, sending as a multicast information. Okay, that is how we can be done by control or checking on the prefix option. There's 4 bits over here. All right, and in detail, we go into one by one on the router LSA, network LSA, and so on. First one we look into it is on the router LSA. Under router LSA, is belong to 2001. It means that if we in the area, and this is a router LSA, a flooding group is within an areas. Okay, each router LSA contains several link description. Each link description is about the information of the interface. Multiple router LSA can be used and they are differentiated by the link state IDs. Okay, you can have a lot of different router LSA, but this router LSA is to just inform you that how the topology is being formed by using this router LSA. So this is under the OSPF v2 router LSA, and this is on the OSPF v3 router LSA. So we have a W over here. We added 1 W. In OSPF v2 is just 0. So from the OSPF version 3, we have a W. This is considered as a M, multicast. So this W is indicate the multicast. That is a multicast route. The V is represent on the virtual connection. Okay, as a virtual connection, it means that a V-link. E is a ASBR. And B as an ABR. Okay, that is the bit to telling you that right now this interface I connected is connecting to the ASBR, connecting to the ABR, is all connected to the virtual connection. Okay, they will give you the ideas of this bit to identify where you're connecting across to. And the type over here, they will have 1 byte. It's based on the type of the link. The type of the link can be a point-to-point, the stub, or transit. Okay, transit link or virtual link. Okay, this is on reserve. The matrix is just the cost. Interface ID, neighbor interface ID, and the neighbor's router IDs. So that's what they identify from here. They show you that what is my interface ID that connecting to this interface, and what is my neighbor's interface ID and the router IDs. So in this case, I will know that based on router LSA, I know who are interconnected with me. This router is connected to me. I can draw my own topology by using the router LSA. So router LSA is not include any information that advertise into the OSPF. This one is more to discover your neighbors. Where is your neighbors? Okay, to define the interface from one point to the other point to form the topology. Okay, this on the router LSA. Okay, router LSA under the link type. The link type just now we mentioned from here, they have a type from here, right? Okay, we have a link type of the point-to-point, link type of the transit, reserve, and also we have a virtual link. So actually they have only 3 types: point-to-point, transit, and the virtual link. When they're described as a point-to-point, the neighbor router ID is a router ID of the neighbors and interface ID of the neighbors. When you are the transit, you show the router ID and the DR of the DR and the interface ID of the DR. Virtual link, router ID of the neighbors, and VLink interface ID of the neighbors. That is what they will show you direct from the router LSA. So they have only 3 types. By using this type, you know that where they are interconnected to each other. Let's look into this example here under the router LSA examples. How they identify that which device which are connecting to which. Okay, router LSA where they're connecting to. So when you check on the display OSPF v3 LSDB routers, router LSA. So right now I'm under router A. Okay, on router A, I will find that I have transit network and also a point-to-point network I can discover. Okay, and this option is REV6. So R, it means that it's the intermediate is the routers. E, they support externals and they are running on the V6 calculation. Okay, this is on the bit. Okay, this is on the information they are sending in this case. And this is the matrix. This is the interface IDs. This interface ID is just random generated based on your interface. Every single interface, they will come up with one single interface IDs. Okay, this is your interface ID. And this is your neighbor interface ID. You can see that this can be the same, but it doesn't matter because you can tell that this is your neighbor IDs. That's good enough. So you can see that from here, this is different. 286 and 206. They are different on the interface ID of the neighbors. Okay, this one is just to tell that this is a DR interface IDs, and the router's ID of the DR is 2.2.2.2. So far, okay. So that can be the same. The interface ID is just random generated based on the interface that you have. Which interface they're using, they come up with the interface IDs. So at least that based on this router LSA, I know that on my router A, I have connected to a DR, okay, to a DR, and the DR router ID is 2.2.2. This is what I know, okay. And also I connect, but this is to the broadcast environment. Okay, to broadcast environment. But what the device belong to this, I do not know yet. I only know that I have a peer go to 2222 as a transit network. And I have another peer as a point-to-point go to 206 and my neighbor router ID is 4444. So it means that I have another routers go to the 4.4.4.4. That's what I know. That this is unmade as a point-to-point. It's not on the transit environment. So based on the router LSA, I can start to build myself with a topology based on the information I collected inside the router LSA. So this information, they not involve any route detail. What they have over here is just who is the neighbors, who is the interconnected with you right now. That's all the information inside the router LSA. Is it okay? For the first router LSA, let's say okay, then we proceed to the next one. The next one is on the change in the network LSA. Okay, network LSA. Under the network LSA, what are the differences over here? They were added in option and network mask, they changed to the interface ID. So the rest will be the same. Attached routers. Who are attached in this environment? A network LSA is generated by the DR and flood within the areas, and network LSA describe all the routers that have a full relationship with the DR on a link. So that is where they are attached routers. Who are attached into this transit network? Okay, that is what they're going to concern into this. Okay, and this option field that describe the capability to set all the router on the link. Okay, you tell that what the capability of the DR does not affect the LSA transmission. They just to tell that within this transit network, what type of capabilities they can support within these areas. All right, and now show you the example from here. Just now we figure out this. Okay, router A, I have connecting to the 2.2.2.2 as a DR. Okay, that's what I know. Okay, but it's not direct connected. It's connecting to a transit network. It's a switch. Okay, from the other side, I know they're connected to the 4.4.4 as a point-to-point. Okay, this is connecting to the multi-access network. And for me to know who are attached into this transit network, I can check on the network. LSDB network LSA. So that is showing you that this is the DR interface ID, this is a router ID for the DR, 222 as a DR. And I see that inside this transit, I have 2.2, 1.1, and 3.3. Means that from here, I can discover another one. That another one is called 3.3.3.3. Okay, that is what I can get based on the router A by using these two LSA. Router LSA and the network LSA. I can discover the topology by understanding the LSA information. Is it okay so far? That is how they are discovered from there. And this is the option field they added in to represent that there's routers that can be support on the external route. Then there's V6 capabilities. Okay, have a V6 capabilities. Is it okay? Up to this on the network LSA before we go further. Okay. So then the next things I will go into and check is be on the link LSA. Okay, a link LSA. Link LSA is a new LSA inside the OSPF v3. Okay, inside OSPF v3. A link LSA is a new type of the LSA added to the OSPF v3. A link LSA is generated by a router for each OSPF v3 interface and flooded on a link. Its function include advertise a local link address as a next hop address to other router on the same link, advertise all IPv6 prefix on the local link to other routers on the link, and provide the option field value of the DR on the broadcast or the MPMN network. Okay, that is what they are involved for the link LSA. Link LSA is more advertising within your link only. I tell all the information within my link. Definitely, let's say for the entire areas, you still need to use the intra area prefix to forward the information. Okay, this one is purely just within the direct connected, within the user that connecting to the same link. I will get this link information. Okay, and this is what inside the structures, the link LSA structures. So they will include, this is on the DR information, option, link local address, and prefix. Okay, that is where they are advertising. So it indicates the DR priorities, and the option, it describes the capabilities, the the option field that they were mentioned earlier on. So this one is total 24 bit. Okay, 24 bits. This one is 8 bits. So in total 32 bits from here. And options is the capabilities, the R bit, the E bit, and the V6 bit. Then the next one is a link local address. This indicate that this is your address for you to calculate as a next hop to reach the destination. To tell you that this is a next hop for you to access before you can go for other segment. And the prefix indicate the number of the prefix that you send. And for others, it be just the prefix length option and also the prefix address prefix that you're advertising into your environment. This is on the link LSA. Yeah, link LSA. So on the link LSA, this is on the examples. So I do it on the router A. Okay, router A. Router A, they have on the serial 6000. I have two prefix, 3000 colon 1 colon 1 colon colon 1 and 3000 colon 2 colon 2 colon colon 1, 48. So under my interface, this link LSA is belong to this interface serial 6000. It's sent as a link LSA. This is my interface index, okay, 2402134, okay, and this is my router originating routers. By router 1.1.1, I send it out, and the option capabilities are EV6, and this is the priorities and the link lockers for you to point for the next hop to reach to the destination. They have two prefix they're carrying. This is the two prefix they're carrying by under this interface. Okay, so they're going to send multiple link LSA. Okay, based on this interface, based on second interface. So in this case, this information they will send to this router D. To say that attaching this link, I have these two IP address. For you to go to this IP address, this is the next hop for you to point to reach to the 3001 colon colon 1 and 3000 colon 2 colon 2 colon colon 1. This is where you're accessing into the destination prefix that you are going through. Okay, on the link LSA examples. Is that okay? All right. So the next one is on the intra-area prefix LSA. So intra-area is also a new LSA we added inside the OSPF v3. So on the OSPF v3, intra-area prefix is just within your areas. You are send all the prefix to everybody inside your areas. It's not only to the link. Okay? Not only to the link. In OSPF v2, address information is contained inside the router LSA on the stub network, and the network LSA is on the transit network. But however, in the OSPF v3, router LSA, network LSA is not contain any address information. The intra-area prefix LSA are then introduced. So they need to add this information into this intra-area prefix to carrying the information to allow them to forward all this detailed information. Okay, because for the default, they are not forwarding anything direct. Is that okay so far? Any questions so far for these intra areas? Let's say there's no question, then we go in more in depth. For the intra-area prefix LSA contain the following intra-area prefix. They have a router prefix, the prefix of the subnetwork, they have prefix of the transit network. So it means that they combine under OSPF v2 the router LSA and network LSA. These are the two information they are combined and combine it into the intra-area prefix LSA. When on the OSPF v2, this transit network will be shown under your network LSA. Okay, and this two is inside your router LSA. But now they'll combine every single thing they share inside the intra-area prefix LSA. Multiple intra-area prefix LSA can be originated by a router or on a transit network. Okay, multi-areas prefix LSA can be originated by routers or on a transit network. So that means that they can create multiple intra-area prefix. Okay, into announce what is on the stop, what is on the transit. Okay, they're going to define multiple intra-area prefix. When compare this on the OSPF v2, router LSA and network LSA are used to advertise intra-area route. In OSPF v3, these two type of LSA do not contain address information, as what I mentioned just now. That's why they need to combine these two into the intra-area prefix. Inside the intra-area prefix, they will tell you that how many prefix that you're sending, the reference link state type, reference link state ID, reference advertised routers. This reference, they will reference back into the type 1 or type 2. Reference to the router LSA or reference to the network LSA. So it means that their reference router LSA means that they belong to the stop. Network LSA, it belong to the transit. Okay, that's what they are representing from here. On the reference link state ID, they have type 1, type 2. Okay, type 1 it is 0, it's normal. Type 2 is the DR interface IDs. And the reference advertised routers, type 1, type 2. Router IDs of the attached routers, router ID of the DR as a type 2. Okay, it's on reference advertised routers. And also the rest is other prefix of all your prefix information that you're forwarding inside the intra areas. Okay, so the connected routers and transit, this is on the reference link state type. So there is a value they're going to be represent what they are sending within your area. So far, okay? So now we look into the example here. In the example over here for the intra-area prefix LSA examples, so we have router A, B, C, D, same things. Okay. When I check on the display, OSPF v3, LSDB, intra prefix. So over here, you show me that there are 3 prefix. They reference back to the router LSA. Okay, router LSA. Under this router LSA, the reference ID will be 0. Okay, this is a IDs 0s. Because it's a routers, it's a point-to-point, so they do not give the DR information. Reference originated router IDs by router 1. It's router 1 who originate this information. Then I have this prefix of 3000 colon 2 colon 2 colon colon 3000 colon 1 colon 1 colon colon 3000 colon 3 colon 3 colon colon 3. This is a local address. This is considered your loopback. Yeah, your loopback interface. That you show that as a local host addresses. So far, okay? That is one of the intra areas prefix. They still have more. They are going to show you multiples LSA. This is one of the LSA come from these devices from 1111. Okay, and secondly, they have another LSA intra prefix. The original routers ID is 2222. Okay, 2222 originate this information. That is reference to the network LSA. It means that that is a transit. Okay, and this is a DR interface ID, and this is a DR router IDs as a 2.2.2.2. Then they will tell you that this is attached devices. 2001 colon 1 colon colon 2002 colon 2 colon colon 2000 colon 3 colon 3 colon colon. So this is information that I will get. Yeah, this is on the address information. Earlier on, you just know the topology. But after topology, I know already. I learned about the addresses from the routers. Okay, intra area prefix. So this is only happen within your area. So there's a 2. There's a 2 prefix I'm receiving. Is it okay? One is originated by the 1.1. The other one is originated by 2.2.2.2, the DR. Is that okay so far? No questions? All right, let me continue. With the next one is called the inter-area prefix LSA. This one will be same as what we know as a network summary. So summary LSA, they will learn as a OSPF v2. That is on the type 3. Type 3 summary LSA. In the OSPF v3, this is called as a inter-area prefix. So that don't confuse it over here. They have inter-area prefix and also inter-area routers. Routers is type 4. Prefix is a type 3. It describes the prefix information of others areas. A type 3 LSA is generated by an ABR and flooded within the areas. And this type of LSA describes the routing information of other areas into the local AS. And each inter-area prefix LSA contains an address prefix, the D2 address prefix, and the LSA does not contain the link local addresses because this one needs to be sent to the other areas. It's not within your link anymore. And LSA using the 32-bit integer as a link state ID to distinguish itself from other LSA generated by the same router. So they give you a unique IDs to tell that this is belong to which routers. Okay, using the distinguish using the link state IDs, unique link state IDs. Okay, so when compared to the OSPF v2 and OSPF v3, so that is the differences. Link state LSH option, then link state ID advertised routers, LS sequence. Okay, that is on the header itself. When compared to the LSA that are sending, is an inter-area LSA. I have a checksum length network mask, 0 type of service matrix on top of service matrix. So when I go back to the inter-area prefix LSA, they have reduced a lot. 0 matrix prefix length prefix option 0, and also the rest of the address prefix. Okay, address prefix. So the link state ID over here, it is just defining that the unique IDs for the OSPF v3. So we need to know what are the link state ID information. It's just a 32-bit numbers used to generating by the same numbers when you are under the same routers. Okay, so that is easier for us to look into the examples from here. On RTC, I will have this inter-area prefix LSA 001. Okay, link state ID 0003, originator ID by 1.1.1.1, and that is have one prefix of 3000:1:48, and this should be sent to router B. So they have more. They have more to go because only one prefix. They are going to be using one LSA. So they are going to have multiple LSA to be forwarded going to the area number 1. Okay, this is between. I will say this is an inter-area prefix. So on the OSPF v2, we translate from the ABR. Am I right? Based on your type 1 to type 3. But under OSPF v3, you also do it on the ABR. But this time I'll convert which one? I convert the intra prefix to inter prefix. Okay, that is where they are translating to. From translating whatever you have intra, I will translate into the inter prefix. Okay, that is where the inter area prefix you come in to the pictures. Okay, inter areas. Is that okay? Grab the ideas of this inter area prefix already. So it will be very similar to the OSPF version 2. But the conversion are different. From type 1 to type 3 become the intra prefix to become the inter prefix. And next is on the change in the type 4 LSA, inter-area router LSA. In the OSPF v2, this type of LSA is called the type 4 summary LSA. In the OSPF v3, this type of LSA is called the inter-area routers. So this is just to tell that who is your ASBR. We call this not summary LSA, we call it the ASBR summary LSA. Okay, a type 4 LSA is generated by the ABR and flooded within an areas. This type of LSA describes the ASBR information, and the inter-area router LSA contain the information about the ASBR. So actually, it be the same. The only difference over here is just that the 32-bit integer or as a link state ID to distinguish itself from other LSA by the same routers. They're just using a unique IDs to identify who you are. So you can see into the structures format, the packet structures, they are the same. Okay, the structure are the same. Okay, except that is on the destination router IDs. They need to put inside the LSA. Where is your destination router IDs? Because based on the link state ID, I do not know where you are, who you are, because it's a unique ID only. Okay. Then next is on the type 5, AS external LSA. Under AS external LSA is generated by the ASBR and describe the routing information of external areas. Okay. So this is on the type 5. So type 5 is the same. The name also the same. It's called the AS external LSA. It's flooded within entire AS. So the whole AS will learn this information. Same to the type 5 in OSPF version 2. A link state ID is the type of the LSA does not contain address information, but is used to distinguish itself from other AS external LSA. This is a unique ID again. And they do not contain any link local address because this one is globally. I do not share just into the link. I share to everybody. So they do not have any link local addresses. Under the optionals, they have a forwarding address, external router tag, and also they have a reserved field on the reference link state IDs. The link state IDs information as a reserve. Okay. So in this case, this is the optional information they added in. Okay, they also have E. E is just means that this is the externals. Okay. F is a forwarding address. Okay, this will be F will be related to this. Okay, when you set 1, I need to check where is your forwarding address I need to point to. Okay, this is a tag, external tag. Okay, when you have tag enables, I have to check on the external route tag. Okay, this is where there are the difference between. Okay, so this is on the AS external LSA structures under the type 5. And how it look like on the type 5, let's say right now on the router D, I'm advertising. I import a route of 3001 colon 1 colon 48 into the OSPF. So in this case, router B, you receive this. Router A, B, C, all you receive. Okay, they have received this as a link state ID, originated by router 4.4.4, and this is the prefix they're receiving. The option, they're not using any option. This is an option. This is an option. Okay, they're not using any. And the matrix, the type is using type 2. Okay, so that is pretty straightforward. They will just alert to you that this information they're advertising direct from the AS external LSA information. So by right over here, when you check on router B, you should receive the LSA. Sorry, you should receive the inter area routers. So it equal to the ASBR summary LSA. Okay, that will be right you receive. You receive and show that that is the ASBR. Okay, and you advertise routers by 1.1 when this is a ABR routers. So I will send this information across. Okay. So far for all this LSA that I mentioned above on the OSPF v3, is it all of you okay? Can able to easy to understand? Okay, maybe I just do a summarization from here. Let me just add a page on this. I give you some ideas. The summarizations. Okay, so we have router LSA, network LSA, network summary LSA. All right. So we also have a router LSA here. Inter areas prefix. You also have this inter area routers. And also we have a link LSA and intra area prefix LSA. So that is all the LSA that we have in the OSPF v3. All right. So when doing the mapping, we can map easily this to this to this, and this is to this. This one will be very simple and very easy to understand. All right. And this is a new. They have no reference back into the router or network LSA. This one is only meant for the link lockers. The link lockers, they will only generated under IPv6. OSPF v2, IPv4, they have no link locker addresses. This one is only sent within your link lockers. And the differences between router LSA on OSPF v3, last time for this, they will have the two informations. Okay, they have two informations. They will show it as a topology and also address. Address of the stop and point to point. Okay. Network LSA, they show the topology and also address of transit. Okay. And now for OSPF v3, this one is only show the topology. This only show the topology. And under intra areas, they will show the address with the stop, point to point, transit, and also VLink. Okay, that is what they can show from here. So it means that they are going to have map topology to this, mapping is correct. And for the address mapping, they will map into this. Okay, that is the differences between the OSPF v2 and v3. What you need to know how to differentiate them. Why in OSPF v3 we need to have a router LSA, neighbor LSA, as well as a link LSA and intra-area prefix LSA. What are the differences? Then you can tell right now. Oh, router LSA, neighbor LSA, it just give me the idea about the topology, but it's not involve any addresses information. There's no address information involved inside the router LSA and neighbor LSA. It just give me the idea how the topology it look like. For me to share the information, I have to use another LSA. It's called intra-area prefix LSA. For me to send the information, need to use this intra-area LSA. Is that okay? For this summarization of those LSA, is okay or not? To understand in between the OSPF v2 and OSPF v3. So what are the differences? Is that all good? Before I continue. Okay. So next, we look into the OSPF v3 configuration method and also a common command. Yeah, a common command. So for the maintenance and also debug, how are you going to debug a OSPF v3? This is some of the command it can be used to doing the maintenance and also debugging. To enable debug OSPF v3 event interface status, LSA, neighbor status, packet, and route calculation, you can always start from debug OSPF, event, interface status, LSA, neighbor status, packet, and also the route by using a debug. Okay, when you enable debug, whichever they send, you get the pop-up from the console message to give you the ideas on what type of information you need to be aware when they send on the debug message. Okay. And also the next is on the display the LSDB information. So this display the LSDB will be different compared to OSPF v2. OSPF v2 they combine entire things in the areas, but for this they want to differentiate. Oh, this is a link LSA. Okay. Let me just change the colors. Okay, they have link LSA, router LSA, and so on. Yeah, they're going to give you the detail of under this link. This is link in between, the link in between. Okay, so they will not show you everything, but they're going to tell you that within this link, what information I have, within this link, what link LSA that I have. Okay, and the router LSA, and followed by the inter-area prefix LSA, intra-area prefix LSA, router LSA, and neighbor LSA. So they over here, they show you that it belong to area 0 or belong to the area 1. So that is the differences they're going to be mentioned over here. So you need to grab some basic ideas how it is be done on the LSDB. Okay. And also inter-area prefix, inter-area routers, prefix AS external LSA, and you also can check on the interface itself. Display OSPF 3 version 3 interface Ethernet 6000. That is how you tell that this is an interface index, and this is a link local addresses. So this is how they represent using the interface IDs. Okay, and this is your link local address for the next hop. And for you to check your neighbor status, you can display OSPF v3 peers to check who is your peers. Okay, who is your peers. And also you can check on the OSPF v3 topology. Okay, on the topology. You can check the topology that on the router A, I have 1 point-to-point and 1 transit. Okay, 1 point-to-point and 1 transit. One is on the serial interface, one is on the Ethernet interface. So I have 2 locations. Okay, I can know that what information that belong to. I have 1 point for router A connecting to the router 4444 using the 600 serial interface. And from here, I will have a Ethernet 600. They are connecting to 2222 and 3333, something like this. Okay, this is what you can get, and this is the DR. Okay, that's how you define. How you're going to check based on the topology information inside your environment, and also display OSPF v3 routing tables. Okay, OSPF v3. This is all the OSPF routing information that you can get. So you can see that for you to go to this destination, you need to use this link locker as a next hop. Go to this. This is a link lockers. Okay, when you go to this, this is a link lockers. Okay, always the next hop for the OSPF v3 will be always is your link local addresses. Is that alright for this information under OSPF v3 routing tables information? And let me just cover everything before I show you. I will do it the lab together on the OSPF v3. Okay, suggestion on the OSPF exam preparation. You need to familiar with all the OSPF command, the policy configuration, the go through the headers, master the display and debug command, as well as understand the case scenario design into the courses. That is what I keep on mentioning, that how you can get from there. You can always refer back to the headers. Let's say you have no idea about which command can be applied into it, you always can refer back into the headers document. And these are the website that you're accessing. All right. So from here, I'm going to do it the lab. Let us build. Yes, any questions? So I'm going to simulate something similar that what we learned. I will going to have a serial interface, Ethernet interface. Let me just, after I will send it, this information to you, you can do it together.